Welcome back. In this section, we shall overview the typical construction details of a counterbalanced vehicle. A counterbalanced forklift consists of several units and systems, namely a chassis or frame, a power-generating unit in the form of either an internal combustion engine in the case of engine-powered vehicles, or electric motors in the case of electric or battery-operated vehicles. A transmission unit that connects the power unit to the drive wheels, the hydraulic system that supplies power and force to the lift and tilt cylinders, a steering system which enables the vehicle to be maneuvered, a braking system so that the vehicle can be stopped and held in a stationary position, and an electrical system which in the case of engine-powered vehicles supplies electrical power to various subsystems such as the starting system and the lighting system. You don't need to know how each unit or system operates in detail, but as an operator, you must be aware of them and know what to look at when you perform certain checks. Most vehicles are built up in an assembly plant. In such a plant, it is possible to get a good look at the major components. The main component onto which all the other components are attached is the chassis. The chassis is a very sturdy metal frame that literally forms the backbone of the whole vehicle. Every vehicle requires a power-generating device. This can take the form of an internal combustion engine, such as this diesel engine featured here. Because an engine needs fuel, the vehicle must have a fuel tank. It is usually fitted into the chassis on vehicles that have petrol or diesel engines. Some models, notably LP gas vehicles, do not have fuel tanks in the chassis. Their fuel is carried in a gas bottle, normally mounted behind the operator. Many vehicles are powered by electric motors, which in turn obtain their power from a battery. Batteries are installed within the chassis. Batteries are very heavy and make up part of the counterbalance mass of electric vehicles. Internal combustion engines are coupled to a transmission. A transmission is needed to direct the power from the engine to the drive wheels by way of a final drive, which we'll see shortly. The engine also supplies power to a hydraulic pump. The hydraulic pump is responsible for operating the lifting mechanism, that is, the fork carriage and the mast tilting cylinders. On electric vehicles, the hydraulic pump is powered by a separate pump motor. A lot of hydraulic oil is needed in order to operate the lift and the tilt rams. Hydraulic oil is held in a tank or reservoir situated within the chassis. Engines and their transmissions are contained within the chassis on special mounting brackets. Axles are in turn mounted onto the chassis. The rear axles are able to pivot, thus ensuring that the wheels stay on the ground. The front axle is known as the drive axle because the engine power is routed through it to the drive wheels. The drive axle contains the final drive components, such as a differential and side shafts. The rear axle is known as the steering axle because it carries the wheel or wheels that swivel in order to cause the vehicle to make a turn. Attached to the end of the front axles, you will generally find brake hubs. Within the brake hubs are the brake shoes that cause the vehicle to stop when the brakes are applied. Brakes are not usually fitted to the steering axle. The hubs on this axle are for the purposes of attaching and supporting the wheels. The drive wheels are attached to the brake hubs. All wheels are secured to their hubs using wheel nuts or wheel screws. Attached to the rear of the chassis is the counterweight. As we mentioned earlier, this large and very heavy unit is needed to offer the counterbalancing effect of the load. The counterweight normally forms part of the overall shape of the vehicle. At the front of the vehicle and attached to the chassis with heavy-duty trunnions is the mast. We have already spent some time looking at the mast and its associated lifting mechanisms in the previous section. The operator's seat is generally mounted upon the bonnet. A bonnet is the name given to the movable panel that covers the engine or battery compartment. As a rule, it is necessary to lift the bonnet whenever you have to make checks or perform maintenance work on the engine or the transmission. In front of the operator is the vehicle's control panel and steering wheel. Various instruments and warning devices are situated in the control panel. We shall be looking at these in more detail shortly. Other controls situated in reach of the operator include the hydraulic control levers, foot control levers such as a foot brake pedal and an accelerator pedal, the park brake lever, and the direction control lever found on some models. Some vehicles have their direction control and accelerator together using direction control pedals. To complete a basic forklift construction, we need to add one more item: the overhead guard, a major safety feature to protect the operator. We have looked very briefly at the major components and basic controls of typical counterbalanced vehicles. We have not seen everything that there is to see, but what we have seen should help you to locate and identify those components that a good operator must know. In the next section, we shall be looking a little more closely at some of the important systems that feature in engine-driven vehicles.